Hey everyone, and welcome to today's Explainer. We've got an incredibly focused, super practical session lined up today, tailored specifically for all the cloud architects, database admins, and IT ops professionals out there. We are taking a really deep dive into the Oracle ZFS storage appliance. But, we aren't just talking about raw storage today. We're actually exploring the ultimate blueprint for integrating your ZFS appliance directly with Oracle Cloud Infrastructure, or OCI, to achieve just absolute top-tier storage observability.
So I want to kick things off by posing a pretty crucial question to all you IT pros watching. How do you actually monitor a powerhouse storage appliance before your users start complaining about a lag? I mean, in enterprise environments, the ZFS appliance is an absolute beast, right? It handles massive data volumes, it's super reliable, but power without visibility, that's a massive risk. Because look, we all know how this goes. The database team is always going to point fingers at the storage team first. If you're waiting for a database to stall or a user to complain about a timeout before you check your storage health, well, you're already too late. We need proactive troubleshooting, and that is exactly what we're going to build today.
Okay, let's dive into this blueprint. First, we'll bridge the current observability gap. Then, we'll break down the OCI integration architecture, track some key performance metrics, walk through the actual practical setup, and finally wrap up with proactive console monitoring. Let's get right to it.
Starting with Section 1, Bridging the Observability Gap. This is all about moving from a state of reactive panic to proactive control. As I touched on a second ago, the ZFS appliance is the backbone for so many enterprise solutions. But the real headache in these complex setups isn't whether the storage works, it works great. The challenge is maintaining clear, actionable visibility across everything connected to it. Historically, managing a standalone ZFS meant dealing with entirely siloed logs. Your storage data was over here, your cloud infrastructure logs were way over there, and troubleshooting, well, that meant manually connecting the dots at like 3 a.m. after something already broke. But by integrating OCI, we are completely shifting to a unified dashboard approach. We're combining ZFS telemetry with OCI services to give you real-time, proactive insights across your entire stack. It's a total game changer.
So, how do we actually do this? That brings us to Section 2, the OCI integration architecture, building the ultimate telemetry system.
This brilliantly illustrates how all the puzzle pieces fit together. We're basically leveraging three main OCI services here. First up, logging analytics. This ingests both your OCI audit logs and your ZFS logs via a REST API. Honestly, consider this your central nervous system for log correlation. Second, we have stack monitoring, which you'll use to onboard your application VMs and systematically test those NFS mount points. And finally, the monitoring service takes all that raw data and visualizes the metrics and logs into gorgeous, unified, single pane of glass dashboards. By weaving these services together, we achieve what's called true multi-stack monitoring. And I really want to emphasize this concept because true visibility isn't just staring at the storage box itself. It's comprehensive operational monitoring that tracks the entire journey from the ZFS client right through the network down to the ZFS storage appliance and encompassing all the underlying OCI components. So, if a user experiences latency, there's no more guessing. You'll know exactly where in the stack the bottleneck is hiding. So, what exact data are we pulling into these dashboards? Let's move into Section 3, Tracking Key Performance Metrics to unlock rapid root cause analysis. For the DBAs and cloud admins tuning in, this is the stuff you really care about.
Now, what's really interesting about this ecosystem is how balanced it is. The ZFS appliance generates an incredibly rich set of analytical datasets. By bringing together system logs to catch those underlying functionality quirks, alert logs for immediate critical warnings, audit logs for security and compliance, and fault logs for hardware or firmware glitches, you effectively create a perfectly holistic view of the appliance's operational state. It's like having eyes everywhere.
And beyond just the logs, you're going to be tracking continuous operational metrics, things like CPU usage to catch processing bottlenecks before they completely freeze operations. You'll monitor disk I/O, read, and write ops to manage throughput. You're going to watch network throughput for any data transfer anomalies. And, super importantly, you'll analyze your NFS protocol operations to make absolutely sure your file sharing services are running flawlessly.
Now here's a critical insider secret you definitely don't want to miss. Because we are ingesting OCI audit logs right alongside our ZFS logs, you have to watch for inter-service API call failures. Specifically, keep your eyes peeled for HTTP 401 unauthorized and HTTP 404 not found errors. Monitoring for these exact status codes helps you instantly pinpoint expired credentials, misconfigurations, or even security breaches that are blocking your cloud services from talking to your storage.
All right, I want to deliberately slow our pacing down just a bit here as we move into Section 4, Practical Setup and Implementation. We've talked about the what and the why, but now we need to look at the how. Let's get into the actual deployment blueprint. Let's map this out so it's a clear, manageable roadmap. The deployment really boils down to 5 distinct phases. 1. Fulfilling prerequisites like IAM policies and your management agent. 2. Configuring the SSL key store. 3. Authorizing your credentials. 4. Deploying the log sources. And 5. Adding that log source association. Let's briefly break down the critical details for these steps. For Step 2, the SSL configuration, this is all about establishing trust. You'll jump into your ZFS UI console settings and download your SSL certificate. Then, using OpenSSL, you convert that certificate from a .crt format over to a .pem format. Finally, you use the JDK key tool to create a brand new JKS key store. This step is absolutely crucial because it securely unlocks REST API ingestion for your management agent. No trust, no data. Next up, to actually authorize that management agent to hit the ZFS endpoint, you've got to handle your credentials securely. You do this by creating an HTTPS-based authentication JSON file containing your usernames and passwords. Once you have that file, you register it directly using the credential management shell script provided by the Oracle Cloud Agent. This just ensures your cloud systems can securely and seamlessly authenticate with your local appliance. For the final major setup phases, you download the ZFS log sources zip file from Oracle and import it right into Logging Analytics. Now pay attention here. The most important thing is to edit that log source and replace the default log URL with your actual ZFS console URL. Once that's validated, you associate the log source with a host entity, specifically a Linux host. And keep in mind, the client host entity type has to exactly match the log source entity type, or the data just won't flow correctly. Okay, that handles the back-end data flow. Now let's jump to our final technical topic in Section 5, proactive console monitoring. This is where we get into fixing problems before your users ever notice a thing, and we do it using synthetic monitoring through Application Performance Monitoring, or APM. Because your ZFS UI console is your primary management tool, making sure it's available is critical. With APM, you can actually set up 2 distinct flavors of scheduled synthetic monitors. The first is a browser monitor. This one is simple. It just pings your console homepage to check availability and response time. Crucially, no login is required for this one. The second is a REST monitor. This one's a bit more advanced. It performs a GET request and actually logs in to check the availability of specific pages, like your cluster configuration page.
So the crucial point here is applying these automated checks consistently. And that brings us to the magic number, 30. When you're setting up metrics extensions within Stack Monitoring to test your ZFS mount points, you really want to set a timeout value of 30 seconds. Why? Well, it hits the absolute sweet spot between detecting connectivity issues instantly and avoiding a bunch of unnecessary network overhead. It makes sure the system periodically and automatically verifies that your NFS mount points are actually awake and responsive.
Oh, and here's a great pro tip for the operators out there who really love getting into the weeds. When you're reviewing your scheduled REST monitor runs in the History tab, you can click View HAR, which stands for HTTP Archive. Downloading this file lets you deeply inspect the exact details of that API run. It gives you just incredible insight into network response times, letting you spot any potential latency bottlenecks happening during the authentication process itself.
Which leaves us with this final thought today. Is your storage infrastructure actively telling you how to optimize it? Because by integrating the Oracle ZFS storage appliance with OCI logging analytics, stack monitoring, and APM, you literally transform a silent storage box into an active, communicative part of your cloud ecosystem. You finally move from reactive panic to proactive optimization. Thank you so much for joining me for this explainer. I highly encourage you to take these blueprints and start building this visibility into your own environments today. Catch you next time.